Hello, my name is Lubomir Bic. I am a professor of information computer science at the University of California. And I'm here to talk about protection and security in computer systems today. So now we have done all these biometrics. Let's turn our attention to the most common way of identifying, which is passwords. And there are two issues. We must protect the stored passwords somehow. They have to be kept in the system, somehow recorded, and they have to be protected so that they cannot be stolen, obviously. And the other problem is we must prevent somehow trial and error. So how do we prevent guessing of passwords? Because after all, these are just words, and anybody can try to guess a password. So let's look at these two problems one at a time. To protect password files, you have two approaches, or two ways of doing it essentially. You can rely on the system, so you just record, you have a file with all the passwords and all the usernames, and it's kept in the system someplace, and unencrypted, and you rely on access control. So essentially only very few privileged users will be able to get access to these passwords. Now that has a problem, because first of all, super users are not supermen, superwomen. They are still human, and they can be corrupted. And if they have access to these passwords, they could be enticed to access them or to sell them or something of that nature. So that's one problem. The other is that if somebody breaks into the system and actually becomes a super user, they would have access to these passwords. So that's a very dangerous thing to do, to maintain passwords in an unencrypted form. So what typically happens, and most systems will actually do this, they will encrypt all the passwords using something called a one-way function. So let's call it H, one-way function. So you take a password, you apply the function, and store the result of that function. Now, one-way means that you cannot go backwards. So you can encrypt it, but there is no H inverse function to actually go back. So you can't, from the stored password, you can't derive the actual password. And so if you know H of X, there is no way to know the password itself. And keeping the passwords in the system is safe, because you don't even have to protect them, because they're useless. Because what happens is at login, you present your password, okay, PW. The system will apply the H function to it, the one-way function, and compare it to the stored value. If it matches, you can go in. If it doesn't match, obviously you are rejected. But so if you just presented the stored value, it's useless, because from that the password cannot be derived. You actually need to know the real password and then do the H function to do this. So this what makes passwords relatively safe to maintain. Now let's talk about the other problem, which is the guessing. So this is a game of cat and mouse, because everybody would like to have a password which is easily remembered, but if it's easily remembered, it's also easily guessed. And so there is always this dilemma between those two. Now how can we sort of mitigate the problem of guessing? Well, that could be a system-generated password. So you don't choose your own password. The system actually gives you one that's reasonably safe. Problem is, if it's a random string of some garbage characters, it will be very difficult to memorize it, so you will write it down, which is a danger in itself, so writing down a password. So sometimes the system will try to make not a random string, but something that actually can be pronounced, like a nonsense word. So that's one way, system generated. Another one would be to validate the passwords, and they have to fit a certain, which is what most systems do these days, they have to fit a certain profile. So they tell you how many characters you must have, minimum, maximum. They tell you there must be a letter, there must be a number, and so on, to make a combination which is much less likely to be guessed. Because the guessing happens in the following way. The password cracking program actually goes through dictionaries. And so for each dictionary entry, it simply takes it and sees if it matches. And so it just keeps going through these words. So that's why you want to avoid common words or anything that is a word in the real world. So it needs to be combined with some of the numbers or some of the special characters. Now the third approach is to use a time limitation. So in the extreme, a password could be used only once, one-time password. That's very restrictive. So typically there is an expiration date, and you have to change your password every few months or every few days, depending on the company or on the policy of the company, just to make sure that if a password is lost, the damage is limited to a certain time period. The extreme case of time-limited passwords is, of course, the one-time. So a password that can be used only once, and then it's invalid. That would be very safe. Problem is, you would have to have a list of passwords, and again, you could not memorize it, so it would have to be in some kind of a list that you would maintain, and it's pretty dangerous. So what happens very often is that you get a smart card, and whenever you press it, it will give you a new password. Every time you press it, it gives a new password. So, for example, I have it with a bank. It gives me some kind of a strange random number. It's not a random number, it has certain properties that the bank can verify. And since this little card that I have could be lost and somebody could use it, it must be used in combination with a password or a PIN and something like a user ID. So it's a combination of these two things which is always used to make sure that that the user is properly identified. Another way of doing these one-time passwords is to use actually a function, secret function, not a password itself. So here's a very simple example. Let's say your password is not a word, but it's a function of this kind. It says, take a number, divide it by 2 and multiply it by 3, and send that to me. So every time you want to log in, the system will present you a challenge. So it will send you a number. Let's say it sends me a number 2. I apply this transformation to it, divided by 2, multiplied by 3, so the result is 3, send 3 back. And so, well, of course, this is a very simple, trivial example of a function, but if the function is more complicated, an imposter or intruder could not guess it, could not reverse engineer it. And so, since you are getting a different challenge from the system, and the reply is different every time, it becomes a one-way communication. So stealing a password, let's say listening to it online, would not be very useful. And here's a third way of doing one-way functions. Remember this one-way function that I just mentioned. So it's a function that you can apply but that you can't reverse. Now you could use it to generate a series of passwords. So you start with something, password, then apply H to it, get another password, again apply H to it, and keep repeating it until you get a series. Now you see you can go easily from in this direction, so from the password to the encrypted and so on, but not backwards. So as long as you are using them in this direction, so first you use this one, you cannot infer the next one from it, then you use the next one, etc. You get a valid series of passwords that cannot be deduced one from the other. And here we have the last approach to making passwords more difficult to guess. It's called system extended passwords. So what happens here is that for each password that a user provides, the system actually extends it by a random number called salt. I'm not sure why it's called salt, but that's what it's called. And what the system stores, as you can see in this picture here, is the user ID, the salt, and then this encoding, which is again a one-way function of the salt and password. So it combines the salt with a password and stores the result of that function. Now think about how guessing works. Okay, the guessing program simply goes through zillions of names and anything it can get its hands on, dictionaries, anything that's on the internet, and it checks if this is a password, if this might be a valid password. So if you don't have this salting, then all you have to do is just apply this function h to any word and see if it appears in the file. And if it appears, then you have a valid password. You have guessed it, right? And that's very fast. So you basically, every word that you can look up in the dictionary, apply the h function to it, see if it's in the file, and keep going. Now with the salting, of course it's not foolproof. It only slows down the process of guessing. It doesn't prevent it, but it slows it down, because you have to do this function h every time for every line, not for the entire file. So for any given user here, you would have to extract the salt, then do this h computation, and then compare. So the computation can be done only for one line because it would not work for anything else. So it's an order of magnitude larger computation effort that needs to be expanded. And so as long as the h function is complicated and takes a long time to do, you would slow down the process or inhibit the process of password guessing.